So pretty much in the last class we were seeing more about how do you do a stash, that is how do you take a backup of the changes what you have done, and how do you reset the changes or undo the changes specifically. Okay, so now continuing with it, there are a couple of other scenarios on how a user will be working and what and all issues you'll be facing. Okay, now all those things until yesterday, what we were seeing is how do we undo a change? That means whatever the developer has done, that is he has modified, how will be he undoing it, right? Now, specifically all those things which we saw now, it was before he commit it into the repository or before he is storing the changes permanently into the repository. But what if the user has already committed, which means say that you have already put the code into the repository, and if you see that you feel that there's something wrong and you want to revert it, so how is that it'll happen? So there are different scenarios, right? Until now, before you were going to submit, that is you had the changes in your working directory, then we changed the changes from our working directory and we pushed into the staging area, and before we put into the repository we were trying to undo, revert, or whatever it is. But now say that you have already committed it into the repository. Okay, then you realize that there is some problem, or after you have committed it, QA or some other person who's testing will try to let you know that there is some bug in the submittal what you have done. So basically you are trying to revert or completely take back the change what you have done. That is what we call it as rollback. So in those case, what is that we will do is that as a simple command for that called revert, this will take back or roll back all the changes what we have done. Okay, so I'll show you what it is. For example, okay, so now, all right. So let's do one thing. I'll add a new line here. I'll say I'm adding line 3 to this one.java. Okay, so if you see, we have added a line called line 3 to the file one.java. So let's quickly add it to the staging area. And once you have added to the staging area, how do you commit it? You will say commit -m and we'll commit it. Okay. So I'm just giving a comment just for our understanding, saying that this is the change what we are going to revert. Okay. So now if you see, we have submitted the change into the repository and you have the change permanently. And let us look at the commit history. So now if you see, this was the earlier one, and currently we have one more new commit ID, right? Okay, fine. So now we have committed it and we have reverted. So now, as I said, we might be doing testing, or QA might be doing testing, or the build team might be taking this change and doing a build. So now they realize that the code is not proper and it is causing problems. So you have to revert or roll back. So simply what we can do is, let me just git revert. Okay, and what is that you are interested to revert? Basically, when you say I am interested to take back the changes what I have done, that is line 3, it is not that you go to the file manually and remove it, because the changes has been stored permanently into the repository. And how does Git tracks all the changes? Guys, it's a question for you. I mean, how does Git tracks the changes? Anoop, Nagesh?
By using the snapshot.
Yeah, what do you call the snapshot here?
It's a commit tag.
Exactly. So It tracks the changes with respect to the commit ID, correct? So now what is the commit ID which we are interested to roll back? This is the one. So now, as I was saying earlier, so in order to represent a particular commit ID, either you can give the complete 40 characters, or you can simply use the first 7 characters of that commit ID. Okay. Oh shit, what is that? Okay, so let me say git revert and just type 9147 ft. Okay, so that's 1, 2, 3, 4, 5, 6, and 7. All right. So now what it has done is it is actually opening up a editor for giving in the comment. Okay, so if you see the default comment, it itself says that reverting whatever the changes what we have specified and the comment for that. Okay, and it is saying this is the commit ID that we are reverting. So if you want, you can add in any comment additionally. If not, let's just save it by default. Okay, so now let's look at 1.java what it has done. So typically what it has done, it has removed the changes what we have done with representing this commit ID. Okay, now we have got back the file to the same state what we had initial. But look at this, what has it done? Do you see what it has done? It has created a new commit ID. So what does it mean by that? So typically, if you see, what is the state of the file? First, we were in this commit ID. Then we added one line called line 3, and that is when we got this particular commit ID. Okay, now when I am rolling back my content of the file back to the original, what do you mean by back to original? We are going back to the content which was there in this commit ID. Right? Now, if I'm going back to this particular commit ID, obviously we should be pointing to this commit ID, right? But why is that it has created a new commit ID? So what do you mean by new commit ID? That means we have some new changes done on top of this commit ID, right? So only when you do some new changes or do some modification, you'll be getting a new commit ID. But in my case, what we were interested is rollback. So that means if I had created a new commit ID corresponding to some change. So when I say rollback or revert this, I should be going to the previous commit ID. So that is what it means. So typically right now, if you see, this was the content of the file then when we were using this commit ID. Now, what do we mean by it is creating a new commit ID? So that logically means that there are some modifications. So what is that modification? So if you see, that is the reason why Git is so secure, because you cannot modify anything so simply and delete the entry. So if you see, what and all are the factors which is going to affect the commit ID? So it is not just the author, it is not just the message, or it is not just the comment. There are various other factors, right? In fact, if you see, date and timestamp is one more factor. So now how Git considers that is, even though you are reverting the content of the file to the previous change or previous commit ID, both are same, but the state of the file is not the same, because here the file stamp was October 20th, but right now when you're taking back the change, the timestamp of the file is different. So logically what it will think is the file states are different, so because of which, even though the content of the file is going to be the same as this, the state of the file is different. So hence it is going to create a new commit ID even for that. Okay, now this feature is not available in any of the other tool, because as soon as when you say revert back, you know what the other tools will do? It will just remove this commit ID, or it will remove this check-in ID itself totally. So that logically, if you are going back to the previous version, then you don't need this, right? But here in Git, it is not like that. Even though you are going to point to the content of the previous commit ID, the various factors like timestamp and all are going to be different. Hence, It is trying to create a new commit ID. Okay, so please remember, whenever you're trying to revert an actually submitted change or commit, you cannot go back to the previous commit ID. Always there will be a new commit ID created. Is that clear?
Yeah.
Nagesh, Anup? Hello? Okay. Nagesh, is that clear with you? Okay, he left. All right, fine. So now, going on to the next topic. Now, what happens? Okay, now let us take on the same scenario. Now, you me being a user or any kind of developer, so you'll be working on so many changes like this. Now, suddenly, there would be a requirement wherein you have to go back to a particular commit ID and do some testing, right? Now say that what will happen on a daily basis, you will be keep on modifying, and for every modifications that you will be doing, you will be getting a new commit ID. Okay, now say you give this to the build team and the build team does some testing, or sorry, they will do some compilation, and they will be doing some unit test internally, and it will take like 1 hour or 2 hours. So in between that 1 hour or 2 hours, as a user, you will be continuing with other changes and you will be creating new commit ID. Okay, so assume the same scenario here, that suppose if this was the commit ID that the build team has taken, so that it has to be given to the QA. Okay, now within that 2 hours, you have modified some new changes and you have put in two commit IDs. Okay, now this is the scenario, and currently, now where is that you're pointing, or what is the head of your branch? Going back to yesterday's class, Anup, Nagesh, or Suranchi, what is the
Yeah.
head of the branch?
So head will be basically the 21st one timestamp one. That one.
Exactly. So head is nothing but the
First one.
latest,
Yes.
yeah, the latest or
Committed.
the current commit ID which you are pointing to. And how do you get the current commit ID?
Right.
If you still don't remember, you can just say log-1, right? So right now, this is where I'm pointing. So now that build, whoever the person is doing, they are saying that there is some problem in it and builds are not working or the code is breaking. So now what is that we have to do? As any user, now I want to go back to this particular commit ID and I have to verify, correct? So now with the existing workspace, how is that we will be traversing between commit IDs, or how will I go back to a particular commit ID? Okay, now for that, we can use the same git checkout command which we have used earlier. Okay, so what was the point when we used git checkout command? Or the question is, when do you use git checkout command?
Branching switching.
Yeah.
Yeah, so when I say git checkout, what were we doing? Basically, we were seeing the branch name, right? So what it will do, it will be shifting from one branch to other branch in the same workspace, right?
Yes.
Okay, now in order to do this, you have to understand is the deep. Now, whenever you say git checkout a branch, logically, if you see, the branch has so many commit IDs which is related to it, right? So are we telling to which commit ID that you are going to point to this particular branch? For example, let me see. So right now, where is that you are pointing? You are pointing to new branch. Okay. Now when I say git checkout master, so in this, if you see, there are so many changes, right? So in this, which is the one that we are currently pointing to when we do a git checkout master? It is this, right? So what is this? This is the latest which is available. So whenever you say git checkout branch, internally, you know how it takes? It will be taking it in this format. So if you are specifying a git checkout, you have to specify it in this format. That is, what is the branch name, and in that branch name, what is the commit ID that you are interested to do. So in that case, suppose if you say just git checkout and the branch, and this value, whatever that you have not specified, then it will assume that you have to go to the latest commit ID which is present in that branch. So that is when, whenever you say git checkout a branch name, it will be pointing to a latest commit ID which is present. Okay, now it is the reverse what we need. That is, I am working on the same branch wherein I want to go to a particular commit ID from one place to other place. So that is what we were doing it here, right? So now if I say git checkout that new branch, so if you know by default, what is the commit ID that it is pointing? It is pointing to the latest, right? So by default, when I didn't say any commit ID, it is taking me to the latest of this branch, whatever it is there. Okay. Now in that, my interest now is I am saying I don't want to go to this. I want to go to a particular commit ID like this. Okay, so now where are we currently? I am already in the branch. So since you are already in the branch, you can simply say it in another way, that is git checkout and just the commit name or the commit number. Okay, so now when you say commit number, what does it mean? It is internally going to take the current branch where you're working on. So it is going to take it like this. So it's dependent on which value that you skip. Suppose if you skip the commit ID, then it is going to point to the latest commit ID of the branch. And suppose if you don't specify the branch name, then it is going to check for the current branch itself. In that branch, it will go to a particular commit ID. So that is what we are trying to do in the next case. That is, in our case now, we are interested to traverse a particular commit ID in the same branch. So simply this logic will work. So is that clear how checkout internally works? So you can use it for switching between branch, or you can use the same git checkout command to traverse between commit IDs of the same branch.
Right.
All right, so let's try that and see. So now where are we pointing to? I'm pointing, or the workspace is pointing to this chain number. And suppose if you say git checkout and a particular commit ID like this 93E9EB. Okay, that will be 1, 2, 3, 4, 5, 6, and 5. Okay, so now just look here what will happen. Did I do something mistake? 93E. Okay, it's 9E. Okay, there you go. So now if you say git log -2, you see, where is that you're currently pointing? You're pointing this. That means the head of the branch, that is the reference of the head of the branch, has been shifted from whatever commit ID that it was earlier to the commit ID currently you are working. So now if you see, you are pointing, or your branch is currently viewing to this particular commit ID, and that is what you're working. Okay, so don't get confused,
Mm.
because what happened to the other commit IDs? Now the other commit IDs are present in the repository. Okay, now what the hell was that? Okay, now going back to the yesterday's or the old. Okay, what is the 3 box again? So what is this box? This is your working directory,
Working directory,
and this is your staging
repository,
area, and this is your
repository.
repository. Okay, so now if you see, you will be having all the commit IDs here, right? So you'll be having a commit ID 1, you'll be having commit 2, you'll be having commit 3, like this. Now, when you say like this, now all of them will be present with respect to a branch. Okay, I'm not just going deep into it because we already seen it. So now, whenever you say git checkout, by default, what is it going to happen? Okay, let me show you that also. Now, this is the branch. In the branch, you will be having this commit ID for a particular file or reference, right? So now when you say git checkout a branch, it is going to take a content of the branch and put it here. Now, what is that it is going to do? Suppose if you say just git checkout branch, then it is going to take the entire content and it is going to put it here. But in our case, we are not trying to do this. What we are trying to do is, I am trying to check out and point only a particular commit ID. Then it is going to give a reference from wherever that you have specified and leaving out the other. Okay, so it is just that the working directory is allowing you to view only from here, wherein the repository still contains all the latest changes what you have done. Okay, so be clear in that. So don't just confuse that why it is not appearing. It is because this working directory just acts as a window to view the things physically. So wherein whatever that you have specified, only that is being taken and working directory is allowing you to see. Okay, so that is what by default, this would be the head reference of the branch for you to currently work. Is that clear?
Yes.
Yeah.
Nagesh? Okay, fine. Now, okay, so we literally saw. Now, how do I go back? Okay, now we have done this changes. Now, how do you go back to the initial commit ID or the latest commit ID? Any guess?
Log one.
Hmm. Guess back. I just told you the answers.
Git log one, no?
No,
Log hyphen one.
no, log-1 is just going to print you, right? But I'm asking, okay,
Yeah.
now I want to refer to this commit ID back. How is that I will get it?
Reward.
What is this commit ID? This is the latest commit ID in this branch. Okay, so how
Yeah.
can I
So
go
that's
back to
the
the
head.
latest? Yes, how can I go back to the latest commit ID of a branch? Just defaultly say
Yeah.
git
Git
checkout
check.
branch, right? Once again, it's going to
Yeah.
take you back. So if
Right.
you say git checkout, and if I say the same branch again, logically it is going to overwrite whatever you've done and it is going to bring back. So now if you see, you're pointing back to the latest commit ID. So it's just simple in that way. You just have to apply your thought over there. So remember, when you
Right.
say git check out the branch, it is going to take you to the latest. And if you don't specify a branch for the same branch, it is going to traverse your commit ID. Okay, now, so all right, so as a user, you'll be doing all those things, but sometimes what happens is you might have to discard some kind of files and it will not be required further to put into the production. So in that case, what you can do is you have to delete the file. Okay, so in Unix or Linux, you simply use the command called rm to delete a file.
Remove.
Yeah, but typically now, if you see, when you do a rm, what is that you are doing? You are logically deleting the file only from the working directory, right? But the content will be still present in the repository. So you cannot just use the normal Unix command to delete only from the directory. So what you have to use is, we have to use a git rm command. Okay, so when you say git rm, and if you use some file, and if you see now, it is actually putting it into the repository also. So now physically the files is not there, and once you have deleted, we can add the changes. Okay, so now totally it is also not present in the repository. Okay, so that is how you ensure that when you want to delete a file, you delete it permanently using git rm command. So if not, if you just say rm, then you are deleting it only from the working directory, whereas the file reference will still be present in the repository. Okay, okay, fine. Now, going back to the previous class sessions again. Now, what will happen if we have so many files and say that we create some class files like this, right? And
Mm,
by default, what will happen if I say git status, it will be considering all those things, isn't it?
mhm.
Now,
Yes.
how do I ignore all of them? Because I don't want to add
Git
all the
ignore files
runtime
is there.
files.
Git ignore files is there. So we have already mentioned that any class file will be there. So it will be not considered by the Git repositories.
Yeah, how do you ignore them?
It defines in the ignore files, na?
Yeah, but that is the right way to do. But if you see, when you try to do a build, it is not just the class files you will be getting. Suddenly you will be getting some text files, right?
Hmm.
Some log file that you put, right?
So we have to put this type of file in the ignore files.
Yeah. Now, one way that you can do is you can keep on adding to the git ignore file. But typically, you cannot put everything like this, right? But because it will be a big pain. So instead of that,
Okay.
what you can do is it some other way that I can quickly delete all of them and then proceed. So in that way, in Git, there is a command called clean. So it will delete all the untracked files. Okay, so what do we mean by untracked? All those files which are not being stored into the repository, right? So if you see, this has been called as untracked files. Now, using this command, you can actually delete all those files which has not been stored into the repository permanently. Okay, but in order to do that, first let's ensure whether what files we need to delete and what we don't want to delete, because by mistake, say that you had a very new file which you wanted to add into the repository, which means you are creating a fresh file. So in that case, even that will be considered as untracked. So by default, if you just say git clean, it will delete everything. So you will be under a toss. So what we have to do is you have to use an option called -n, which will be used for a dry run. So when I say dry run, it will just let you know that what are the files that are possible to be deleted. Okay, so now if you see in this present workspace, it is saying all these files which you have listed down are untracked files and they can be deleted using the git clean command. Okay, so now once you have verified that this is fine, and you can go ahead and submit if you had any other file that you have modified it and you submit it. Once that is done, you can simply say before clean -f, that is forcibly you're cleaning it. Okay, you'll just delete all those things. So it is just a simple way, because there will be different kind of users, they'll be doing different kind of builds or testing, and there'll be so many runtime files they have created. Okay, so it'll be a big pain for a user to remember that they have to add. So simply what they can do is they can just use a git clean -n to verify and delete all those files later. Okay, okay. Any doubts until now?
Mm,
Nagesh? Okay. Nagesh? Okay, cool. Fine. Now, let's go on to a next topic. Okay, so before that topic, okay, I just want us to know what is your understanding when you hear a word called tax. Okay, so don't just think from technical perspective or Git perspective. Generally, when you refer to a word called tag, what do you mean by that in general?
You can recognize something with the tag associated with it.
Exactly. What others?
Yeah.
Why do you use tags for?
For sharing some, you can say that data and you can say that comments for that particular ID or particular uh, themes. You can say that.
Don't read the slide. I'm just asking general. Haven't you heard anywhere or have you not used a tag anywhere generally? You would be seeing price tags in the shop, right?
Yeah.
Yes, 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 yes.
What is the need of price tag? Or any kind of tag that is attached to your cloth or anything else. So it is basically a reference, right? And a quick identification so that using that you can know the complete details about whatever that you wanted to see. So in the same way, what will happen in your production is that we will be having so many commit IDs. So just like what we saw, every time you do a commit, there will be one commit ID that is present. And now, if you see the central repositories, there will be so many commit IDs that is happening and everything will be stored. Now, every time you promote a build and you give it to the QA and it qualifies that you can release it, okay, how do you exactly track what was the commit ID that you have given to a particular release? It is not so very easy, right? Because remembering that 40 characters or 40 digits is not an easy thing to do. So in that case, what you can do is you can use a concept called tag, wherein as the name indicates, you can tag a particular commit ID so that it will act as a quick reference. So whenever you wanted to point to that particular commit ID, you can refer to this tag so that internally it will be referring to the 40 characters commit ID. Okay, now the problem is how do I recognize the tag? So every company will have their naming convention to point a tag so that it will be easy for them to remember and easily recall anything that is needed. So the very first thing they would do is they will have their own string format for a tag. Okay, now based on that, no matter what release you're doing, you will be easily identifying. So for example, say that you are doing release. Okay, so they will have a tag name always starting with R. Okay, or release, anything is fine. So that means this is the tag which is used for release, and then they will be using some string like this with representing the major, minor, and the patch release. Okay, they will be doing it like this. Okay, so now if I follow this format, no matter what kind of release I'm doing, I'll be creating a tag in the same order. So I can say like this: release underscore 1.2.4 or release underscore 3.3 dot something like that. Okay, so
Right.
now quickly, if I want to refer, all I have to remember is what is the format or the string naming convention that I've used. So simply we will be referring to the particular commit ID what you have. Okay, so it is not just like this. Suppose if you want, you can also mark what build that a QA has taken. So even for that, you can take something like a timestamp and you can apply it. Okay, so tags act as a quick reference through which you can identify a particular commit ID. So, okay, so now how do you basically create a tag and apply? So you can create a tag in two steps. That is, you can say git tag and the pattern, that is the naming convention that you're going to use, and apply it later. If not, at a one stretch, you can say git tag -a pattern, which means it will create the pattern first, wherein followed by -m represents what comment that you're using to create, and then at the end option or the last option, if you specify the commit ID, it is going to apply whatever tag that you have created onto the commit ID respective to that.
Commit ID.
Okay. Okay, suppose if I want to apply it to this, so simply we'll say git tag -a, and let me say test underscore tag. Okay, I'm just using some string, and then I'll say 001. Okay, and then we will say some message, our first tag. All right, and then we have to specify the commit ID, so we'll say 3354103. Okay, so it has done. So how do I know whether it has done? So what you can do for that is you can just simply say git and tag, and that will be listing your all the tags that is present in your workspace. Okay, so if you see, there is only one tag that is available. Now, at any point of time, if I want to know what are the details that it went into this, you can use the same command called git show, which is used to identify what and all you have done into the commit ID. Okay, so now if I say git show and test tag whatever that we have used, you see it is going to internally point to the commit ID and whatever changes that is done. So this is equivalent to saying what? Saying a git show of the commit ID, right? It's one and the same. So now if you see, I am trying to say or see the contents of this tag, wherein this tag is a reference, and first thing it does is when it was created. Okay, and what is the comment? And internally what it is pointing to? It is pointing to this commit ID, giving you all the details about that commit. So like this, you can create multiple tags and you can attach it to a particular commit ID so that you can have a reference and you can quickly try to identify what commit ID was used for a release or a build. Is it fine? I'm sorry, actually, it might be network. So in case if you don't clearly listen or say something, just repeat it. I'll repeat it. Is that clear? All right. So coming to the last topic of Git, pretty much there are many other things, but that's not used on a daily basis. So now, until now, what we were seeing is more from a daily developer workflow kind of stuff, wherein what he'll be doing, what and all problems he'll be facing, and how do you basically try to get a workaround for that. Okay, now there's some topic called Git bisect. Okay, so since you guys are focusing more on DevOps, why is that Git is being put into the DevOps is because one thing is it is quite lightweight and it can be used not only for development, but you can also use it for maintaining any kind of code which a build team or QA team or being a DevOps engineer, you can use it, right? That is one of the main purpose. But in additional, if you see, DevOps also focuses mainly on providing automation as much as possible. So in that case, using Git, you can do certain automation with respect to build management. Okay, so when I say what is that, so the question comes like, if you take back the previous example of revert, what we were saying. So now you have a change that you have modified, you have committed, and you have given it to the build team, wherein they have integrated your commit with so many other commits, and they are trying to do a build so that they can give it to the QA and verify things. Now, what will happen is suddenly that they find that the problem in the build and a particular commit ID is failing. So at that point of time, if you see, it would have taken like 2 to 3 hours to do the build, and in meantime there will be so many commit IDs that has already gone in. correct? Now by that time, how do they try to recognize what is the exact commit ID which is causing the problem? Because there might be n number of changes that is going in, and it'll not be easy for someone to do. Okay, so let me try to again use the notepad and show you what it does. So take the same. So assume that like this, say you have commit ID. Okay, so what I'm trying to say is, assume these are the commits which people keep doing it on one of the other. Okay, now if you say QA would always be taking all the integrated code for testing. So in that case, the build team will be taking at some point of time some change, and they'll be trying to do the build. Okay, so assume that yesterday or at some point of time they take one commit ID like this and they try to do the build. And once they do the build, say it will be passing. Okay, things are completely fine. Now after that, the next day the QA wants to take some latest change for testing, so they will ask the build team to give a new build. So now if you're trying to see, there are so many commit IDs that has been gone into the repository from the last time we did the build. So right now, what is the latest commit ID that is available is this. Okay, so now say that the build team is trying to do a build here and the build fails. Okay, now the question comes here is, what is causing to the build, which is which code is causing the build breakage? Now what is that we have to do? The only thing what we have to do is wait until the developer comes back and fixes the problem. Okay, so for that you need to identify what is the particular commit ID which caused the problem, right? So how will you find it out? So I am saying you have so many commit IDs. So now if the build is failing at this commit ID, or if the code is not compiling here, so does that mean the commit ID 10 is the culprit, or it could be anyone between these? How does that work? Hello?
Yeah, well, I think that if it fails on commit ID 10, then it should be the one which is bad.
Okay. Suppose you take this much. Okay. I have created a new file. So assume that there is a file called one.java. Okay. And I added one line and I created commit ID 1. Okay. Now then say that I added one more line and I created a new commit. Okay. And here say that I created a line 3 which is buggy or which is faulty code. Okay. Now I
Oh,
added
yeah,
line
yeah.
3. Now if I keep on adding like this, now once I come here and if something fails here, does that mean commit ID 10 is the culprit?
No, no, no. It can
No.
be anyone. Yeah.
Exactly, because you create commits on top of the existing one. So logically, you don't know what is the problem, right? So how will you
Right.
try to find it out? How will you try to find it out? So one way what you can do is you can go to each of the commit
Each
IDs
of them. Right.
and try to do some build step, whatever you're trying to do, and ensure which one is failing, right? Suppose
Right.
if this passes and until this it is failing, that means this was the commit ID which has created the problem. Correct? So
Correct.
logically you have to traverse between all the commit IDs. So how will you traverse between all these commit IDs?
Mm.
Come on guys, just now we saw that. How would I
The
traverse
checkout
between? Yeah, exactly.
use. Yeah.
Anup, Nagesh, we use checkout, right? If you say check out a change number or a commit ID, it will be pointing to that particular commit ID, isn't it?
Right.
Yes.
Okay, so now like this, you can go to one by one and try to find out what is the culprit. Now what will happen, suppose if to do this build step, it takes close to 10 minutes. Assume that it takes 10 minutes. Now, how much of time you will be wasting? You will be wasting 10 minutes, 10, 10, 10, 10, 10, 10. So that means closely you are going to spend nearly 50 minutes just to find out what is the buggy code. Okay. And
Right.
top of that, if you had more than 10 changes, then what will you do? So if you had 100 changes, then
Man-
are we going to spend
Manually we
two
It will be
days for
very
that?
tedious. Right.
Then we need certain kind of automation, right? Logically, this is the only way to do it manually. But instead of
yes.
doing it this way, we can use the concept of bisect, which is present in the Git, which is an advantage over these kind of steps, what you do. Now, how you do is that in the Git, you have to specify a range where you want to bisect. So when you say bisect, as the name indicates, you are going to divide the change numbers in such a way that it will be easy for you to identify what exactly is causing the problem. Okay, now for that, what you need to do is you need to give a range of commit IDs between which Git has to try to find out what is the culprit. So in that case,
Okay.
what is the range that you have to give? The range is what was the last successful commit ID on which the build happened, and what is the current commit ID on which the build is failing, or the last okay commit ID and what is the current failed one. So you can call it as
Correct.
good commit ID and bad commit IDs. Right?
Right.
So you have to give that range. So when you give a range like this, so if you say the bad change number and the good commit ID, okay, so now in my case, I will say 10 and 0. So that means it has to consider the range between this and this, and what it has to do next thing is you have to tell, okay, now you're saying that there is some problem between this commit ID and this commit ID that you want to find. But how does Git know what is the exact problem? Our problem is when I'm trying to run some build, it is failing. So along with specifying this range, you need to specify a script which will run those exact steps what you are running, and it will try to find out what is the problem. Okay, if not, it doesn't know anything about what build does, right? Because each product
Mhm.
will have its own build. So logically, you have to specify these three things to the Git. That is the bad change number or commit number and the good commit number and a script. And this script should have all the logic on how do you run the build and output correspondingly, which means if the script exits a value called 0, then that means whatever step that you're trying to run is success. Suppose if it exits any other value other than 0, like 1 or 256 or whatever, then that means that the script failed. Logically, that means that the build failed. Okay, so like that, you can run the script in such a way that the Git will try to understand, okay, as soon as it tries to go to a particular commit ID and it runs the script, if it returns 0, that means this step is passed. And if it returns any non-zero value, then that means that the step is failed. Okay, fine. Now, how does Git performs the bisect? So when you give a range like this, what Git does first is it splits the change or commit ID into half as a range. Okay, now after it splits, what it will do is it will try to first do a build here. That is, it will try to run the script. Suppose if it returns a non-zero value, then that means it is failed. Okay, fine. Now, if 6 is failing, what is the logic meaning that 6 is failing and 10 is failing? That means anything between this will also fail. correct? The
Right.
base itself is failing, so 7, 8, 9 should also fail because 10 is failing. So then what it will do, it will skip by testing all these things. So the next thing what it will do, it will come down. It will try to test this. Is it success or fail? Suppose if it is fail, then that means 5 is also failing, 6 is also failing, so I don't have to test all these things. So immediately what it will do, it will take the next range. Now the range has been changed from 5 to 0. That is, anything between this could be a problem, right? It
Right.
cannot be a problem anywhere here because 5 is also failing, 6 is also failing. Then immediately it will take the range as this. And now what it will do is it will try to bisect it and see what is happening. Okay, so once again what it will do, it will do the same thing where first thing it will try to test this here. Suppose, as I said earlier, I have introduced the code where in this, right? If you see, I said I introduced a buggy code in this commit 3. So first it will check, okay, it is failing. So if 3 is failing, 5 is failing, so obviously 4 should fail. So it would not test this. It will come and check this. Okay, so now when you check it here, it will be passing because this code works fine. So now if you see, it will try to understand, okay, 2 is passing and 3 is failing and 5 is failing. So logically the problem is starting from 3. So the commit ID 3 is the buggy code. So that is how it will quickly try to traverse, and within how many runs, basically if you say within just 3 runs, it will quickly find out what is the buggy code. So no matter how big the change number list is, it will try to bisect it in this way and it will give you the exact commit ID which is causing the problem. Getting it?
Yeah.
Yeah.
Okay, now let's try to work it practically and see. Now typically since we don't have an environment to check the build is passing or failing, so what we'll do is let's write one script, a simple script to check for a file existence. Okay, so then we will try to do, so first what I'll do is I'll try to create one new file. Okay, so I'll say I'll create 4.java. Okay, we have created 4.java and let us add. Okay, and now if you see, what is the commit ID created? This is the commit ID that we have created. Okay, now let me add some more commit IDs just to represent that there are multiple changes done. So we'll add some content to 4.java. Okay, and we will try to add it. Okay, fine. So now if you see, you have so many changes. Okay, if you want, we can add a couple of more, but just to stop for the demonstration for easier understanding, I'm just stopping one. So now we have created so many commit IDs. Okay, in that, I want to find out where is the commit ID in which 4.java was created. Okay, so let's quickly try to write one small script to do that. Okay, now I've just written one small shell script. So I'll just create this. Hmm. So what I'm going to do, okay, this is the biggest problem. Okay, so what this is going to do is we will be passing file name to the script as a parameter. So what it is going to do is it is going to check whether that file exists. Suppose if it exists, then it is going to print file exists. Okay, and it's not just going to exit it, wherein it is going to return code of 0, which means it is success. And suppose if the file doesn't exist, then it is going to print a message that file doesn't exist. Okay, and then it is going to exit with code 1. So let me just try to give a permission for that. Okay, now let's try to run this as a sample and see. Now if I say 4.java, it says file exists, right? And if you say the return code of that is 0. Now if the same thing, if I say 5.java, it says file doesn't exist, and what is the return code? If you see, it is a non-zero value. So that means it is a failure case for this script. So this is what we are going to do. Now, how is that we are going to bisect this? Like I said, the first thing we need to tell to the Git is what is the range, and the second thing is what is the script that you need to run against each one of them. Okay, and for that, how do you do it? First thing is you have to start the bisect by specifying the range, that is from the bad change to the good change. Okay, so now we will take this. So I will say git bisect, and what is the bad change? It is this 1 2 3 4 5 6 and 7. Okay, and then what is the good change? Assume that this is the good change, right? So we'll say 1 2 3 4 5 6 7. Okay, so it'll going to start. Okay, so it will just prepare itself. Now what we have to do on the other way is you have to say git bisect run and what script that you are interested to run, so that it will automatically try to bisect from this place to this place and bring it automatically. So now if we say git bisect run and 1.sh, and if I give the path as 4.java, is internally it is going to bisect everything, and if you see, it will stop at that place where it is exactly finding the match of what we have given. So it is important that whatever script that you are writing should do the exact check, because Git will be just bisecting. So whether it is going to be passing or failing has to be written in such a way that the script will take care. So now if you see, it had bisected these 3 changes. So first it went ahead with the current change, the build failed. I mean the script returned what? A 0. So then it went to the next step. So wherein if you see the file is existing. So the before going to this place, if you see, it is not there already, right? So it came back to the original place where we returned it success. That is when that means the file is existing and it is going to stop at that particular commit ID. Okay, so this is one of the automation what you can use specifically for build improvements, wherein this is going to say that this is the commit ID which is used to represent a particular problem. Okay, and they will be using all these things internally, saying that you can find out quickly on what is the buggy code or what is the commit ID which is actually causing the problem. So it might be from an interview point. I mean, it's not mandatory that you should be using it, but it's just good to know in case someone asks you what is the big difference between Git. You can say this is one of the additional advantage what you have, but it's not mandatory that you should be using it always. It's just one of the future. If you want to enhance your build revert concepts, then you can use this.
Okay.
Any doubt?
No doubt. Doubt in this topic. I have one doubt in matching concept.
One second. So anything from the current one?
No.
Nagesh,
Yeah, no.
Anup. So no doubts in what we saw.
No, no, in this section I don't have any doubt.
Okay, fine.